Okay guys, we're in Algebra 2, Mod 8. Did not have any notes or homework yesterday. Kind of had a day off to look at your grades and get caught up and make sure everything's looking okay. It is now Thursday, April 23rd. We're going to start a new chapter, a new unit. It's a very short chapter or unit because even though this is called Algebra 2, we do have to get you introduced to trigonometry, just a little bit to get you prepped for what next year, whether you're taking college algebra or advanced math / trig. Trigonometry is going to become a pretty well-used topic in terms of attacking a lot of different problems for at least a few units. So we're going to introduce you to it today, continue the introduction for the next couple of days beyond this. So a nice little 3 or 4 day unit, that's all, just to get you introduced with a background on basic trigonometry, a lot of which you probably saw in geometry last year, or at least some of it you saw in geometry. So really pay attention this first day on this foundation we're going to build and kind of go from there. So top left corner of your paper, 4/23/20. Again, today's Thursday, April 23rd. That's the date. Title, simply put, Intro to Trig. We're going to introduce you to some trigonometry basics. So Intro to Trig at the top. And we're actually going to start your notes by defining what the word trigonometry even means. And you hear that word trig or trigonometry and oh my gosh, it's a scary word. What's it involved with? Guys, basically all trigonometry is, and write this very basic definition on your paper, write down it's the study of the measurement of triangles. It's the study of the measurement or measurements of triangles. Now that says triangles, so it encompasses all kinds of triangles. We are going to focus on what kind, and you should remember this from geometry. In geometry, when you got introduced to trig and had the old sine, cosine, and tangent stuff, does that ring a bell at all? Wasn't it basically the study of right triangles? So with that in mind, I want you to go to your notes, your paper, draw as nice and neat as you can, a nice, neat, pretty big, pretty tall, right triangle. Now the legs do not look like they're the same size here. I've got a side A. I'm making a right angle in the corner. I've got a little bit longer side down here called side B. And then that side that's across from the right angle is our longest side, that's side C. So label this corner capital A, that corner capital B, this corner capital C. And remember the rule from geometry, if angle A is in this corner right here, the side that's across from angle A, you're going to label as side A. Angle B is up here at the top, so the side that's across from him is little b. And if our right angle, go ahead and put the right angle symbol in the corner, is capital C, so it's angle C, across from that, the littlest side is side C. Okay? So the rule from geometry is what? Angles are always capital letters, and sides are always lowercase letters. And the lowercase letters match up with the angle that's across from them. Okay? Now, if you look at that triangle you just drew, we've got angle A, angle B, angle C. Do not look at the right angle C. We never use angle C, the right angle, as our, quote, reference angle. We're going to refer to one of the other two corners, one of the two acute angles. So for now, just to pick an angle, let's focus on angle A. Everybody circle angle A on your paper and make a note that with a star, using angle A as our reference angle, just like it says on my paper. I want you to make a little note and say that we're using angle A as our, quote, reference angle. A reference angle simply means the angle we are referring to. We're referring to angle A and focusing on angle A in this picture. So if angle A is the angle I'm focusing on, There's names for those three sides. Do you remember this from geometry? Watch. The one side that everybody probably remembers is the name of the side that's across from the right angle. Remember that guy? The side that's across from the right angle, the longest side of your right triangle was always called what? The hypotenuse. So guys, write down the words adjacent, opposite, and hypotenuse. Write down adjacent, opposite, and hypotenuse. The hypotenuse in this picture is certainly side C, because it's the side that's across from the right angle. Agreed? Now again, remember, angle A is our reference angle, so put your pen on angle A, or your pencil on angle A, or your finger on angle A. What about those other two sides, A and B? Do you agree that side A is across from angle A? It's opposite angle A. So the opposite side is side A. And then what would you do to describe side B? Isn't it right next to angle A? It's right beside it. Oh, anything that's right next to or right beside something is adjacent to it. So the adjacent side on this picture is side B. Okay? So every time you've got a right triangle, depending on the reference angle you're picking, you've got an opposite side, an adjacent side, and a hypotenuse. Okay? And actually, those three words, adjacent, opposite, and hypotenuse, are now used to represent the three main trig functions that you're going to use in trigonometry. So everybody go next to that picture you just drew. Write the two words trig ratios, and I want you to write the sine of angle A, and we're going to put a formula for him. Give yourself some room, write cosine of angle A, and we're going to write a formula for him. Give yourself a little room and write tangent of angle A, and give yourself a little bit of room to write down his formula. Ignore the other three words on my paper for a second, and just focus on sine, cosine, and tangent. Now, hearing the words sine, cosine, and tangent should allow you to remember good old, okay, put this in quotes up at the top of your paper. Whether you had Mrs. Snyder or Mrs. Moser or Mrs. Gottschall maybe for geometry, you should have been mentioned or taught the word SOHCAHTOA. Everybody write SOHCAHTOA at the top of your paper. Now, SOHCAHTOA stands for something, right? The S stands for sine. Oh, if you ever see the word sine in trigonometry, it means opposite over hypotenuse. So for our formula for sine, I want you to put op over hype. Opposite over hypotenuse, okay? Sine is opposite over hypotenuse. Cosine, I'll go back to SOHCAHTOA. If you follow the letters up here, S, sine is opposite over hypotenuse. Okay, let's keep going. So C, cosine must be what? Adjacent over hypotenuse. So for cosine, we're going to write adjacent over hypotenuse. And then finally, tangent, again, refer to the word SOHCAHTOA. If I start on the left and work my way across, keep thinking with me here. Sine is what? Opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So for my tangent formula, the tangent of angle A, it's opposite over adjacent. Okay? So those three values, sine, cosine, and tangent, are the three main values you're going to see on your calculator. Okay? Now, what about the other three words that you're about to write down? All right. It says CSC, SEC, and COT. Okay, you ready? That means cosecant, secant, and cotangent. The cosecant of angle A, the secant of angle A, and the cotangent of angle A. Those three are considered to be, ready, reciprocals of the three main ones. So guys, even though you're not going to hear very often or use even that often the words cosecant, secant, and cotangent, they are trig words, trig ratios, that are the reciprocals of those first three. So, if we've already established that sine is opposite over hypotenuse, cosecant, who's the reciprocal of sine, must be what? Flip him over. Hypotenuse over opposite. Since secant is the reciprocal of cosine, if cosine is adjacent over hypotenuse, when I flip that over, I get hypotenuse over adjacent. And finally, cotangent is the reciprocal of tangent. So if tangent was, remember SOHCAHTOA? Opposite over adjacent, you've got to have those three memorized. When you reciprocate it or flip it, cotangent must be what? Adjacent over opposite. Okay, guys? So one really important thing to memorize, or point out or emphasize, you need to memorize this little group right here. When we move on tomorrow and we start solving right triangles and look for its missing pieces, oh, you're always going to use words like opposite, adjacent, hypotenuse, and you got to know how they relate to each other by memorizing SOHCAHTOA. So you've got to have this in your notes. You will have this out every day for the next 2 or 3 days when we do a little bit of trig, and you'll refer to these formulas every day. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Okay? All right. Then the other thing, last thing on today's notes, the two special kinds of triangles that you're supposed to already be familiar with. If there's a 30, 60, 90 triangle, okay, and I'm just reviewing this from geometry last year, but it does start to come into play when we do special right triangles in trigonometry. Everybody write a triangle that's got a really tall left side, kind of a short bottom side, and then connect up the two corners, and that, of course, is my right angle right there. Now, guys, there is one special kind of right triangle in the world called a 30-60 right triangle. I mean, these angles that I'm pointing at, the two acute angles, could be any size. This could be a 20-70 right triangle. It could be a 10-80 right triangle. The one triangle that's really special, there's actually two of them, but the first one we're looking at is a 30-60-90 triangle. And I'm emphasizing this because they do utilize this word or this special kind on some ACT questions, so we might as well throw it out there and remind you of this special right triangle from trig. Okay, first of all, if this bottom side is the little side, or the small side, and then this tall side is the longer side, we're going to call this S for the short leg. This side I'm going to call L for the long side. And that side over there, of course, is the hypotenuse because it's across from the 90-degree angle. So if this is a 30-60 triangle, the short side always has the littlest angle across from it. So guys, put 30 degrees up in that corner, put 60 degrees in this corner, and we have created a 30-60 right triangle. And all I'm doing in this block, in this section of your notes, is reminding you of a rule that you had in geometry that gets carried over into trigonometry. This short side down here, let's say that I'm just going to pick a number. Let's say we took out a ruler and measured the short side here, and let's say that that short side was 3 inches long. Okay, I'm just picking a number. There is a rule on a 30-60 triangle, okay? First of all, the hypotenuse of that triangle, believe it or not, is always on a 30-60 triangle. The hypotenuse is always twice as big as whatever the short side is. So if the short side, the little side here is 3, you double it, you times it by 2, the hypotenuse would be 6. And then what about the longer leg of the two? The longer leg, believe it or not, is always radical 3 times bigger than whatever this short side is. So whatever that short side is, in this case it's 3 inches, you times it by radical 3, and that's how big the long side would be. So guys, if the short side would have been 5, the hypotenuse would have been what? Double it. Would have been 10. And how big would the longer leg have been? It would have been 5 radical 3. Just something to remind you of from last year. And then the other special triangle was a 45-45 90 triangle. Obviously, if two angles are the same size, you're going to predict that what? Two sides will be the same size. So draw a nice, neat isosceles triangle. Remember that word? Where this side on the left is the same size as that side on the right. But because those two sides are equal and it's a 45-45 90, we actually want them to create a right angle in that corner. So guys, I'm trying to point out that if those two sides are the same, they're the sides coming together that have to make the 90-degree angle. So technically, when you draw a 45-45 right triangle, you should draw it, watch this, so that you've got one leg the same size as the other leg and make the right angle in between them. Does that make sense? So I've got one leg here that's the same size as this leg down here. So I'll put an L and an L for a leg and a leg. When you connect the two legs up, that's the side that's across from the right angle. So that's H, that's your hypotenuse. And the rule, again, I'm just simply trying to remember this from last year because it's something you're supposed to carry forward here. Let's say, again, we took out a ruler and measured this side down here. And again, let's just say it was 3 inches long. How big would the other leg be? Oh, well, this is a 45-degree right triangle, isn't it? So if the two angles are both 45, the two legs are going to be the same size as well. So if this leg down here is 3, that leg there is 3. And the hypotenuse is always, okay, it's not twice as big like it was over there. That's on a 30-60. On a 45-45 triangle, the hypotenuse is always, believe it or not, radical 2 times bigger than either one of those legs. So it would be 3 radical 2. Okay, guys? So officially, we are calling this our reference sheet for trigonometry. You're going to refer to this sheet and have it out every day the next 2 or 3 days. So the next 3 days, we're going to spend on introducing you to how trigonometry works, how these formulas are help used to solve pretty cool problems. So guys, there's really no problems that we did. The assignment for today was simply to pay attention and take really good notes here. Hopefully you did that, because you'll have this paper out tomorrow and Monday and Tuesday when we start doing some trig problems and doing assignments at that point, okay? So great job. This should be in your notebook. Again, it's today is Thursday, April 23rd. Introduction to Trig, good old SOHCAHTOA. This should be in your notebook. And tomorrow, when you get on and view the video lesson for our first day of trig problems, have this out and ready to go as a reference sheet. There's no homework for tonight. Hey, 2 nights in a row, take the night off from doing homework or turning me in an assignment. But have this paper out ready to roll tomorrow, and make sure it's your reference sheet for the other 3 days of trig that we're about to do, okay? Hope that makes sense. That's a good introduction. Take the night off from homework, and we'll see you tomorrow on the 24th. Great job.